Hey everybody, welcome to our video lesson on data displays part 1. We're going to talk about dot plots and box and whisker plots today, and we do have a couple other ways to display our data sets. So I'm calling this part 1, and then we'll worry about the other versions in the next lesson. All right, now today I'm going to be working with quantitative univariate data. And we went over these in our last lesson. Quantitative means that it is measuring numerical values, and univariate means that I'm only measuring one variable at a time. So these are data displays that only work towards quantitative univariate data, and if you don't have those, then you're going to have to seek other options. All right, but grab your notebook, make sure you have your calculator. It will come in handy today, and let's go ahead and get started. Our first version is a dot plot. So I'm going to dive right into an example. This one's pretty self-explanatory, so I think visually seeing one done is going to be the best explanation that I can give you guys. All right, so the following represents battery life of several different cell phones in hours. So one cell phone lasted 12 hours, one only lasted 9 hours, etc. I'm going to display this data in a dot plot. All right, because looking at a list of numbers like this doesn't really tell me too much about cell phone battery life. All right, I might use these numbers and go into my calculator and find some measures of central tendency or measures of variability like we've talked about in our couple of last lessons. But sometimes visually seeing all the data is what's going to tell us a lot about what we can expect, in this case in terms of cell phone batteries. So in order to create a dot plot, we first need to start with a number line, and you can customize your number line to fit your data set. So I always like to give a little glance. What is my lowest value? What is my highest value? And it looks like here I'm going to be dealing with 9 hours all the way up to 21 hours. So I'm going to start with 9. Okay, sometimes you might want to count by 2s, count by 5s, count by 10s, depending on how big your data set is. I'm hoping with the segment that I drew here, I can fit every number from 9 to 21, but I might not label them all. So let's see if I can do that. All right, and I had just enough room to get all of my numbers 9 through 21. Do the best that you can when you draw your number line to evenly space out your intervals. Make sure that you're counting by the same amount every single time, whether that's by 1s, 2s, etc. All right, and now once I have my number line and I know that number line is going to at least cover my data set, it can go further if you want. I am going to go ahead and place a dot over each number to represent one of my cell phone measurements. All right, so if I start to the left, and if I start on the left and work my way to the right, the first cell phone has a value of 12. So I'm going to put a dot over the 12 to represent that value. And then I have one at 9, so I'm going to put a dot at 9, and then one at 11, one at 10, one at 13, one at 14, another one at 10, another one at 11. Let's speed up this process. All right, so I just went down the line and I placed a dot to represent each membership measurement. Sometimes it'll be dots, sometimes it'll be X's, it could be little check marks or icons, whatever it is. But now I have what's called a dot plot, and I have a visual representation of my entire data set. I can very easily see from a dot plot that my mode is 10. I can also tell the range here because now I have my maximum 9 and my maximum 21 and my minimum 9. I can subtract those two. A little bit more difficult to find things like mean and standard deviation. You're better off plugging the numbers into your calculator or working with a long list. But this can also tell me where my data falls, whether it's nice and symmetric and there's a center value that I can look at. This data seems to be pushed a little bit towards the left. We call that skewed data, where a big chunk is on the left and then there's some on the right, or vice versa. It could be a big chunk on the right and some on the left. So this is not what I would call normal or symmetrical. This is something that would be considered skewed. All right, and up next we have something called a box and whisker plot. Now this might look familiar to some people because some have experience with this in middle school, but for anyone that's not familiar, this is named a box and whisker plot because we have a box and then we have two whiskers on the outside. Mathematicians are generally not creative when it comes to names, unfortunately. But it is, again, hovered over a number line. So that number line, just like the dot plot, is going to be very important to us. And this measures Regent scores. Okay, now each one of these little line segments, vertical line segments, has a meaning towards us. So this first one all the way on the left-hand side, that's going to be our minimum value. Okay, it's the furthest that my plot reaches to the left, so it is the smallest score that I would have seen in my data set. And very likely, or very similarly, the furthest to the right is the maximum score. Okay, so you'll see two little end caps on your box and whisker plots, one to represent the lowest or the minimum value, one to represent the highest. Okay, now the line through the center of our box, that is our median. Okay, remember the median is the physical middle of your data set. So this median would represent having half of the value on the right hand side and half of the values on the left hand side. That would be our center number, physical center number of our data. Okay, now these last two, these also split our data, or they split our halves, I should say, into halves again. So this box and whisker plot is actually divided into 4 segments. You've got 25% of your data falling in between the minimum and this value. Then you've got 25% of your data in between this value and the median, 25%, and then another 25% to make up the full 100. So there's 4 different sections of our whole data set, which helps me to remember that these two represent what's called quartiles. Think of quarters, like there's 4 quarters in a dollar. Quartile is a number that splits, actually we can do that, is quartiles are the 3 values that split your data set into 4 equal parts. So this is our minimum. That's not one of our quartiles. That's just the end cap. This represents quartile 1, and we use Q1 just as a shorthand. Okay, we've got this first fourth of our data split by this number, which looks about like 57 or so. And then we've got our median. That's actually going to represent our second quartile, Q2. That always splits us into halves. And then this third vertical line is going to represent the third quartile, and that's Q3. Okay, so if you haven't already, pause the video. The quartiles are the 3 values that split a data set into 4 equal parts. And I'm going to show you guys what that means in terms of a data set and working backwards, if you will. Okay, so here I have a list of values. I'm not sure what they measure, but I did luckily have them in order. Okay, so if we were to by hand find the median, that would first split my data set into 2 halves. So I'm going to go from the outsides. I'm just going to work my way in. I'm not going to mark anything up, and it looks like 23 is my median, aka quartile 2, because 23 here is the number that has half of the data values above it and half of the data values below it. So this number splits my data set into 2 equal parts. Well, if I want to split my data set into 4 equal parts, I need to split the lower half into 2 halves and the upper half into 2 halves. So what we do is we actually go from the bottom segment and we repeat the process that we'd use to find the median. I'm going to work my way in, so the 23 and the 20, 22 and the 21, and then this number in the middle of those two, that would be quartile 1. And then over here on the upper half, I'm not using the median, I'm just looking at the upper half, I work my way in towards the middle, and this one would be quartile 3. Okay, it's always like left to right. Quartile 1 splits the lower half, quartile 3 splits the higher half. And that would be how we would find quartiles by hand. Luckily, I'm going to show you guys that we don't have to do that. But before we move on, I do want to talk about something called the interquartile range. Shorthand, this is called IQR. Some of you guys saw that come up if you looked up an answer to the most recent Castle Learning. But this interquartile range is the range between the highest and lowest quartiles. Again, we're not very clever mathematicians when it comes to naming things. Interquartile quartile range is just quartile 3, the maximum quartile, minus quartile 1, which is the minimum quartile. Okay, the cool thing about the interquartile range is it's always going to measure the middle 50% of our data set. So quartile 3 to quartile 1 is always going to section off the middle half or the middle 50% of our data. And this is a great measurement of variability that goes along with range and standard deviation. If my middle 50% is really, really close together and I only have a quartile range of like 1 or 2, then I can say that my data doesn't vary very much. If my interquartile range representing the middle 50% of my data is spread out over 100 values, then I can say that I have a pretty varied data set, and a larger interquartile range goes hand in hand with a more varied set of data. Okay, so there's a lot of information that we can get from a box and whisker plot, like the median, like the quartiles, the maximum, the minimum, and certain percentages. But let me show you guys how to actually create your own box and whisker plot in case you're looking at a data set and you want to visually see it, or if you're asked to do so. All right, so here we have a data set representing the number of hours spent on schoolwork each week. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values to work with. And now I could go by hand through this process of rearranging it so it's in order from least to greatest, finding the minimum, the maximum, the median, and the 2 quartiles, and that would help me build my box. But we also have the capabilities of doing this by calculator. So there are 5 numbers that we need in order to create a box and whisker plot, and we call it the 5-number summary. Okay. Every time you're asked to create a box and whisker plot, you're going to find the minimum, quartile 1, aka Q1, put that in parentheses, the median, which is also known as quartile 2, quartile 3, which is Q3, and the maximum. Okay, and going down this list should have values from least to greatest. And the easiest way for me is to use my calculator, plug in all of these data values into my stat list, and I'll show you guys exactly where to find that when you calculate. So I'm going to go to Stat, Edit, clear out whatever's in there, and I'm going to go ahead and punch in these numbers so that I have the list in my calculator. Okay, so all my numbers have been put in. I'm going to again press Stat, but now I'm going to go over to Calculate, and we are only measuring one variable, so I'm going to select what's already highlighted, 1 var stats. As long as that says L1, I'm going to scroll down to Calculate, and this is a very familiar window that we've seen before. There's my mean, there's my standard deviation. Neither one of those numbers is necessary right now, so I'm going to scroll down, and you'll notice the last 5 numbers on this list are my 5-number summary. So I have a minimum of 2, a quartile 1 of 3, a median of 8, a quartile 3 of 10, and a maximum of 14. So those are my 5 numbers, very important to build my box and whisker plot. So I'm going to go ahead and draw a number line. Again, you want to make sure that your number line is going to at least fit the data that we're dealing with. And here we have numbers. We have our minimum of 2 and our maximum of 14. So figure out how you're going to count your intervals. All right, again, I was lucky enough to fit 2 through 14 on my number line. If you're dealing with bigger numbers that span over a wider range, you might have to count by 5s or 10s, and no big deal. All right, but now I'm going to take my 5-number summary and I'm going to transfer it onto my number line as 5 vertical lines. So my first one is 2. Okay, my first quartile is at 3. My median is at 8. My quartile 3 is at 10, and my maximum is at 14. So instead of doing the dots like a dot plot, we're going to actually use vertical lines with our 5-number summary. Okay, now the whisker always goes from your first line to your second. The box always goes around the 3rd to the 4th line. And then your second whisker goes from the 4th line to the 5th. So I've created my box. Here's my median, and here are my whiskers on the outside. Okay, now that I see this visually, I can tell that half of my students spend less than 8 hours on homework. Half of them spend more than 8 hours of homework. I can say that the lowest 25% spend between 2 and 3 hours, and the highest 25% spend anywhere between 10 and 14 hours. Okay, I can also tell that I have an interquartile range of 7, 10 minus 3. So my middle 50% of students have a variability of 7 hours between the amount that they spend on homework. Okay, so those are dot plots and box and whisker plots. Please let me know if you have any questions about this lesson, and there will be practice assignments tomorrow. Have a great day, everyone.